Okay, welcome to your Kin 225 lecture. Today's class, we're going to be going over carbohydrate oxidation. This includes two pathways, metabolic pathways in the mitochondria called the Krebs cycle and the electron transport chain. And we're also going to cover whole body carbohydrate oxidation. And this involves two pathways called the lactate shuttle and the Cori cycle. So this is a review from last day. Which enzyme can be used as a marker of glycolysis? The correct answer here would be C, your glycogen phosphorylase. So lactate dehydrogenase M and phosphofructokinase would technically be enzyme markers of glycolysis. And pyruvate dehydrogenase, you can consider that as aerobic glycolysis. That enzyme will direct pyruvate into the mitochondria where it can be broken down aerobically. So your best answer here is C, glycogen phosphorylase. And this is the pathways of glycogenolysis and glycolysis that I've posted before. You can see that glycogenolysis involves the breakdown of glycogen, whereas glycolysis involves the steps from glucose 6-phosphate down to lactate. Glycogen phosphorylase is at the top here. It's involved in the breakdown of glycogen in the process of glycogenolysis, whereas your phosphofructokinase and lactate dehydrogenase, and that would be the M form, are located in glycolysis. Which enzyme would you expect to increase with aerobic endurance training? The correct answer here would be your pyruvate dehydrogenase. So out of all these enzymes, your pyruvate dehydrogenase is the only mitochondrial enzyme, and it's only the mitochondrial enzymes that increase with aerobic training. So pyruvate dehydrogenase is that mitochondrial enzyme that's involved in getting pyruvate into the mitochondria instead of pyruvate forming lactate outside of the mitochondria. So what happens once pyruvate or lactate enter the mitochondria? So I went over this last day, how if you have a lot of mitochondria in your muscle, it can take up either pyruvate or lactate. The benefit of that is that you'll get less lactate production and less susceptibility to fatigue because of acidosis. So if you have a great amount of mitochondria, your mitochondria can take up pyruvate and through the pyruvate dehydrogenase reaction, convert the pyruvate to acetyl-CoA. Your pyruvate dehydrogenase is a mitochondrial enzyme, and you can see you can also take up lactate through this lactate dehydrogenase H reaction. That H stands for heart. Lactate can be converted to pyruvate in the mitochondria. So again, this is a mitochondrial enzyme. And then pyruvate in turn can be converted to acetyl-CoA. So once it's converted to acetyl-CoA, then that enters a further metabolic pathway in the mitochondria that will further break down your carbohydrate. That metabolic pathway is called the Krebs cycle, and I'll be going over that in the next section.